Welcome to another edition of Models to Ace, presenting an Excel spreadsheet based model for tracking the daily progress of the project. This is a model for tracking and reporting purposes. The spreadsheet has a table that feeds data to the model. These are grouped module-wise along the rows. Here, data is captured across 4 modules in a sample project end-to-end. Data for each of these modules must be captured day-wise for a total period for say 14 days, shown along the column D through Q. The model uses a user-supplied input for average daily productivity of a single worker or resource. Here we have used a hypothetical value of 5.8 tasks per day. The most insightful section in this spreadsheet is a set of progress and trend charts plotted for a pre-selected number of days. For instance, the large graph onto the left displays for a period of 8 days the progress on total number of tasks completed by all project resources taken together. This is the aggregated across all 4 modules that make up the entire project. This is plotted alongside the corresponding planned number of tasks for those 8 days. We will now examine the various sections of the model. It has a single tab named the Progress and Trend tab. The inputs to the model go into the module level data section. This data should ideally be entered by the module leads for each module. The model then computes data in the aggregate data section using simple built-in formulae. The model then automatically generates the section containing charts, which gives you visual insights into the progress and trend. This table can be used by the project lead to feed data to the model. Each module has 5 rows of data, 3 of which, that is, the actual count of tasks completed by the team on a given day, the number of planned resources loaded to that module, and the quality level must be fed by the module lead. The model then computes the planned task count based on the number of resources. It also computes the percentage of target tasks completed by dividing the count of actual tasks completed by the planned count. So the data for the first module, module 1, can be found in the highlighted section for each of the 14 days. The data across all modules are available for each day in each of the columns D through Q for the 14 days. Data for day 6 is highlighted separately along column I, since aggregation across days for a module will be performed till day 6 in column S. This is the same set of data for module 2, for module 3 and for module 4. If you want to add data for a new module, we recommend that you copy an existing module, say module 4, as we show here. Insert the module in between any 2 existing modules. That way you will not have to rework on the aggregate formulas and chart. Excel will automatically recompute the formulae and replot the charts without you having to break a sweat. See here how Excel has automatically reworked on the project level aggregate data, including the newly added module. This section is where the model computes aggregates across all the modules in the project. Column S is where the model computes cumulative totals for days 1 through 6 for each of the modules. The model also aggregates these cumulatives across all the modules of the project in the total across modules section. Down below the table are the progress charts obtained as output from the model. In the task progress chart on the left, 2-line graphs are plotted. The red line depicting the planned number of tasks for each of the 8 days from day 1 to day 8. So what are the independent variables that need to be supplied as inputs to the model by the project leads? Broadly 2 categories. The project level input data. You will have to supply the average daily resource productivity. You also need to specify the day, say today or day 6, till which data is to be accumulated in column S. At the module level, you need to specify the number of resources you will load for each day. The module leads will also have to supply the actuals. Here in column V4, key in the value of the average daily resource productivity for your project. The model uses this value along with the planned resource count that you supply for a given day to compute the planned number of tasks to be completed for that day. In the formulae in column 6, you will have to specify the day, say day 6, till which you need cumulative progress since day 1. You can also automate this using VLOOKUP so that the model cumulates till today. For that, you will have to replace the day headers in row 1 with the actual dates. Key in the planned resource count for each day against each module. For example, 6 resources are loaded on day 1 to module 1. Using the data we just supplied to the table, the model calculates metrics at both the module and project levels, such as planned task counts, the percentage of targeted tasks completed, cumulative quality till today or a pre-specified day 6, cumulative progress on tasks till today or day 6, aggregated daily total across all modules for each of the module level metrics, cumulative progress in column S for each module, aggregated total across module. Planned workload for a module for a given day is computed by the model as a product of the resources loaded and the average daily resource productivity of the project. This average can be sourced from the historical data or organizational process control baselines or industry standard. The model computes cumulative quality till day 6 as the sum of individual daily quality levels divided by the cumulative total count of tasks completed till day 6. All the other cumulative values are simple sum totals across the 6 days for a given module. Similarly, the project level totals across modules are simple totals. Now, to avoid hard coding row numbers references in the sum totals, we use a simple hack. We use an obscure column C. The contents of this column are hidden by using the same font color as the cell background color. Here we use white. This column labels each row against each module with a number which is the same across modules for the same line item, say 4 for percentage quality. The advantage of this hack is that we can do a running total across the entire length of a column across all the modules using some if. For example, total planned workload for day 1 is a running total of column D from rows 2 through 21, but only for those rows which have the value 1 in the obscure column C. This filters out the first row for each module. The advantage of this method is that when you add a new module by copying an existing module and inserting it in between two existing ones, the values in column C gets copied too, and the formula remains valid. Thus, you need not perform any rework on the model or the charts when you add a new module. The same holds good when you delete a module. What are the insights that we can derive out of the project progress model? We can visualize the movement of the actual progress worm against that of the planned progress to take necessary corrective action. We can detect untoward deviations and variations in the resource counts or quality. The task progress chart spanning across rows 29 through 76 uses an obscure data set concealed using white font color in the rows 78 through 80. Even though we have data for all 14 days in this hidden table, we can select a subset of these, say for the first 8 days, for the actual plot on the task progress chart as shown here. Ideally, these two worms should move close to each other. The orange worm falls slightly behind the red worm. This indicates slower progress than planned. Large gaps between these worms are usually indicative of problems and require attention. Let us now look at the data set behind the chart, percentage actual versus planned. Next, let us look at the data set for the chart planned resource count. Finally, we look at the data set used for the overall quality trend chart. Thank you for giving Models to ACE the opportunity to serve you with our analytical models. Please subscribe to our channel.